I'm privileged to introduce my friend and neighbor, Jeff Palmer. Uh, Prior to his retirement, Jeff spent 50 years developing software and 25 years as a college professor. During that time as now, Jeff has been a modeler. What does that mean? Jeff loves to build structures, bridges, scenery, and locos. More specifically, Jeff's interest is in logging and mining, which means Jeff likes narrow gauge. It's the free form and ruggedness that surrounds logging and mining railroads, the scenery, and the landscape. Jeff is always on the lookout for new techniques and tools that will improve the hobby. Model railroading allows Jeff to expand his skill set, work with his hands, and share with friends the things he has learned. About 2 years ago, Jeff completed his MMR, or Master Model Railroader designation from the NMR. During that journey, Jeff had the privilege of meeting many of the modelers he looks up to, like Gil Freitag, Dwayne Richardson, Chuck Ellis, George Celios, Dave Ravella, Dave Frary, Scott Mason, and others. Jeff's goal is to be recognized in this group someday. So Jeff, if you want to go ahead and share your screen and take it away.
I'm going to start with the basics because this is where, guys, we hurt ourselves in so many different ways by trying to cut corners, trying to be a little cheap, trying to save a few bucks here. And as Mark can say, or can relate to, plywood that we're using for a lot of the layouts and building some of the risers and so forth. We got into some plywood that when we started cutting it up, the plywood literally fell apart. Absolutely fell apart. And Dwayne Richardson, myself, and Kenny were looking at it in amazement because it was just crap. But bubbles in the plywood. Unfortunately, this was one that had been finished and nobody had bothered to notice until they had stained it, that it had bubbles in it. There are indications that things are not going well if you look at the edges of the plywood and find separation of any kind, especially at the corners. That's where you kind of want to look. Obviously the risers. Now, I have nothing against risers or anything like that, so please don't read anything into it. But one of the things that we do to ourselves, because it's us building the track, is we're not always real good about making sure we get the risers square. Now, the problem with that is that most of the time the track will run unless you're headed into a switch. That's where the points become a problem. And the fact that the train is leaning and one side or the other causes a few problems. I'm a dedicated user of the MicroMark digital level. You can also buy them at home, similar levels at Home Depot and Lowe's and other places. This particular one I've had for many years, and but they are now commercially available just about everywhere. So to be aware, it's a handy little tool because you don't think of side to side slope, slant, whatever the right word is, on the track until you get into it. But we eat, sleep, and breathe slope because narrow gauge and logging. So I'm always looking at 2, 3, 4% grades, for lack of a better term. And so if you start turning those percentages into degrees, which is that middle column right there, it doesn't take a lot to screw up your train as it approaches a switch, especially on like a downhill slide. That's where I ran into a couple of those in a layout that I was working at and trying to figure out what was wrong, because every time I put the NMRA gauge on there, it was spaced right. The wheels were in good set because I checked the trucks. And then finally I broke down and found, I looked at what's going on and what was happening, and it wasn't happening all the time. It was happening on the very last car to enter the switch, and that caboose's truck, front truck, would derail because of hitting the frog. It's one of those things that you run into. The other thing I find that we really screw up a lot on, or a lot of people have, is Homosote. Now, this is not putting down Homosote. It's putting down our use of being cheap and doing our own roadbed. This is not, no, Homosote's great. I love Homosote. But I have seen and worked with a lot of friends that will go out and buy their sheet of Homosote, cut it up into the sections or the size they need for their roadbed, put the slope on each side of the roadbed, cut it in half, go through and flip it around so that it all of a sudden it doesn't match up. And when I say it doesn't match up, this is what you see. It's not a big slant until you put a gauge on it, and all of a sudden you're several thousandths out. And what does that do? Nobody, failure to mill the top, for lack of better terms, run the pieces through I can't think of the name of the piece of equipment right now, but it basically sands the top off of whatever you put in there, or to run it back through the table saw and level the top. Basically, I call it milling. If you don't, mill the Homosote and you try to match it up, it won't happen. Homosote is compressed paper. Literally, they shred paper, throw a little sand and other solvents and glues and stuff into it, turn it into a slush, pour it into a form, then press the water out. And it doesn't always work well. It makes for a very non-uniform surface, which is great for doing scenery, by the way. It's just, we got to do something in order to have the roadbed. On our models, we don't have the latitude that the prototype world has on their pieces of equipment, where they've got thousands of pounds mashing down on the track and basically leveling it out as it goes, so to speak. Our track doesn't move. And even though we've got thousandths of an inch right here, if you don't shim it, roadbed is not going to necessarily stay there. So, I mean, your ballast is not necessarily going to stay in there, because I've heard all of those terms all along. And I can tell you, I have spent tens of dozens of hours fixing bad roadbed. I had a curve that had several dips in it, and every time there were cars that would not go through the dip, especially for you O-gaugers. Your trucks are terrible, no offense intended. They tend to, especially like the passenger car trucks, as you're on a solid, basically a solid truck, and all of a sudden you have one wheel of the three wheels in the air. Well, that one wheel is going to, most likely creep up, especially on a curve, the inside of that rail, and you're going to suffer a derail. That was the problem I was having in this particular gauge. I literally had to tear out an entire 48-inch curve that was on this O scale layout, and rebuild that entire curve in order to fix the problem. There were just too many dips because the Homosote was not taken care of. It's a problem. Just an FYI. Just show what the effects are with Homosote that's uneven. That is not an exaggeration. took some of the Homosote that was being used, put a piece of track on it, and measured it, and that's 1.9 degrees. If you go back, that's about the slope of a 3 or 4% grade, and that's how you're leaning in this particular case. Not a good sign. I'd hate to even think about how bad that would be, going through a smaller scale track, because this is, and this, well, I'm sorry, this particular photo, I am using HO track. So that's one, but and it might be a little bit less of a slant if you're on the O scale, but it's still, we're looking at 3-4%, what we consider a 3 or 4% grade as a lane on a straight piece of track, or worse, a curved piece of track. There are companies who actually put out, it's the what we used to do is Homobed, and there is a company now that does that. It's called Homosote. You can look it up and you can Google it and do it on the website. The greatest piece of if you're doing your own Homosote and to fixing it up, this video, which is on YouTube, and by the way, this entire presentation is on the Lone Star Region website. I'll have the URL, but the LoneStarRegion.com website under track work, I think it's what it's, that's the topic that it's under. The you can get the URL off of there, if if nothing else, so you don't have to scramble through or write it down. But one of the things that Homosote is not a milled product. It is not smooth. It's not intended to be. It's intended to be a soundboard. And for that, it does an extremely good job. We happen to use it for our needs, and it happens to be a great roadbed. It's just that we need to take care of it because it's not a milled product. Mycore, which is a milled product, it offers a lot of the same advantages of Homosote. The biggest difference being is that Homosote, you pull out a nail or a spike and put it back in, no problem. That's so well on Mycore. Mycore, when you open up the hole does not fill in, does not close. But unlike Homosote, one of the other things I've seen people do to their Homosote is over wet ballasting. And what I mean by that is Homosote is an extremely porous material. Again, it's cellulose, it's paper, wood, wood pulp. I've seen people who poured their 50-50 glue, or even the 25-75% glue kinds of things onto the ballast to glue it down, and I've watched it change shape. So you can't overwater them. Mycore, that's not as big a problem. I push a little bit on Mycore because I sort of like it. I love Homosote better, but if you're looking for alternatives, it's a good one. The other thing for a roadbed that I run into that I have been using a lot of in a number of railroads that I've worked on is Spline. On the right there, you see open spline, what I call open spline. I'm not sure that there's a better term for it or not, but and then you have the solid spline on the left. I was introduced to solid spline back east when I was meeting with a few friends of mine on the West Coast at a convention that was going on at that time, and learned more about the open spline, which I have built a number of pieces of. There is nothing wrong with spline as long as you do the one thing that makes sense. You finish the top. It's got to be even across the top. One of the things we were fighting and all the other stuff is the unevenness of the track. Models are not exactly prototype engines and don't exactly behave that way. This is a picture I borrowed from Joe Fugate. I write for him, so he allows me a few privileges here and there. And he is very much a solid core um, spline person. And in this particular case, he actually turns his spline into the roadbed. Before, when we were looking at the previous one, you had to put, these guys have to put roadbed on top of this. Obviously, you would put roadbed on top of the open spline, and you can see at the top, very top of the picture here, that that's exactly what you have to do in order to make it usable and workable. I like Spline. I need more experience with it. It's a very interesting way of putting track on risers and make it work quite well. Again, making sure that you level it. Now, another form that I love foam for scenery. It's very flexible. It allows me to carve it in various things using various hot knives and so forth. I mean, all the tools, as far as that goes, you can use just a regular, kitchen knife if you want to carve. It's a little bit more work that way. But the one thing that I have a problem with that I have seen more than once, I've read all the material that Lou Sassy has put out on, because he uses foam almost exclusively on his. He must have people who do not lean. Now, I don't know about you guys, but I don't care where I go. We tend to lean. We tend to put our elbows on things. The problem is that the foam does not recover. Yeah, it'll come back up if you put it in a little bit, but it does not come back flat. And I've seen it distort tracks and track work, especially around switches when people were trying to lean and do something with a switch on foam. So just beware. I love it for everything but track work. I do not like it for sub roadbed. Or as far as that goes, if you try to use it for roadbed, which is one of the products here, if you have used it successfully, I'd like to know a little bit more about it. I have used it several times, and I have torn it out and thrown it away several times. It just doesn't work for me. If it works for you, I'd like to know a little bit more about it, but it has nothing to do with Woodland Scenics, other than the fact that they happen to be the people who manufacture this. Because I use a ton of Woodland Scenics materials and other products, so it's not personal. But in most of the cases, using a foam tack glue, I found Anglings did work quite well. I made the mistake when I would first put down the foam roadbed. I put tacks on it to hold it down and hold it in place. It soaked up the glue and sort of stayed there. So, you learn by your mistakes. And so I made a lot of mistakes with foam. I love to learn how to do it better. But for roadbed, I am very much a cork person. I do a lot of cork work, and I rely on it a lot. Between cork and Homosote, those are usually my materials of choice, because I can do all of the things I need to do with pins and they call them foam nails there, but they're just T-pins that I used to use when building model airplanes. So, but the long and short of it, no matter what roadbed you put down, you need to sand. I show a sanding block here. It's just straight old commercial sanding block. But what I actually use probably more than anything else is a 12-inch 2x4 that I have stapled sandpaper to sand my roadbed. It allows me a good length. It allows me to keep things even, and has made for a lot smoother roadbed over the years. I've had a lot less trouble with it, but this will work also. Now, the biggest problem that I have run into is track. All track is not created equal. Yeah, there are other people out there besides Atlas, Micro Engineering, Walthers and Pico who make track. And so to keep this thing in a reasonable size and do what I need to do with the presentation, this is what it is. But this is an end view. I am an HO person, and therefore all of this is code 83 that you see in front of you. As you can see that every one of those pieces has a different shaped head. So, code 83 is not code 83, is not code 83, is not code 83. There's work that's going to have to be done when you made up Pico to Walthers or to ME or to Atlas or any of the other interchanges in between, just matching up the heads so that you don't present a place where the flanges on your wheels will catch. Now, most of the time, it's no big deal. They'll just slide right by. Where you get into the problem is if you change vendors on a curve, or you did like we were talking about earlier, you have track that leans. You run into problems. It's not a problem that you can't, with a file and a few other little tools, get around. But compile a little table here. Part of it's borrowed from Joe Fugate again. He was the first time I saw somebody who actually put a table together. I had a similar table, but since he published his, and I added the last column over here. The one thing that Joe did not address was what I call track profile, which is the last column. The track profile is from the bottom of the tie to the top of the rail. There is a huge variance in there. And so, we're going to talk about mating the things up, but, mating up the track from, say, a Walthers, who has the lowest or smallest profile, to the other guys is a problem. You better plan on doing some shimming. And just going in there and putting a joiner and then soldering it together does not solve the problem, because the track is still going to flex even after you ballast it, because it doesn't have any support underneath it. And or unless you go to the extra time to make that support. Besides that, you also got a 20, somewhere in the neighborhood of about a 20 thousandths that you need to make up. And so you want to flare that out, or you just want to have that one bump right there at the junction. Which brings us into some other problems. If you look at the base width right here, this is where we start talking about whether or not, and let me go back a slide, you're going to hit your joiners, is going to hit right across here. And as you can look, they're not equal. So you need to, the joiners is an interesting problem. And because it's different thicknesses and the widths are close, but that's where it really leaves off. I don't know what this is a typical thing that I see trying to made up code 83 rail, trying to illustrate it. And I see, and it doesn't make any difference. You're using code 100. I have a friend of mine who did most of his track in code 125. And then all of a sudden he threw in a code 100. And I think he just ran out of code 125 and decided that he had some code 100 sitting around. So just, put them together at that and solder the joints together and all be done. Yeah, well, as you can see, you need a little bit smoother transition because the rails are not exactly the same. And a little bit of work. And the last thing you want to do is provide a place for flange issues, especially again on a curve. Height differences, we were just talking about. It's, there's some shimming work that needs to be done here. It's not a lot, but it needs to be done. I found that the best tool for me on fixing those issues is if anybody can recall the old whoever worked on their car, the ignition points that I used to have in the distributor. This is an ignition point file, so you can get that in your favorite automotive stores. They still have them. You can get it off of Amazon. You can get them off of just about anywhere that sells automotive supplies of any kind. So you can find them on eBay. You can find them on Amazon. You can find it, like I said, at your store. It's an aggressive file. It will take down and allow you to match up the rails, inside joints of the rails nicely, and like I said, minimize the work. One of the problems that we come into that I see a lot of is a thing called a kink. I show the kink at the top. It doesn't look like much. This is a mild one, and I could probably get away with it, except in this case, I was going to, it's going to be a curve, and you can see where it just doesn't work right. I came across a pair of pliers that I thought I'm a tool junkie. So guys, if you don't, you can ask Al Collins. I like tools. I'm a big fan of having the right tool for the job. These are jewelers. These particular eyes are done by jewelers. They used it for straightening out bracelets and necklaces, especially solid wire bracelets and necklaces. But it works well for also working with track. I show it in this particular case, bumping track. The problem which you have at a joint like this that we're talking about right here is that it's parallel. And so the pressure on a bend is to the outside. And so you're going to kink, if you're going to do it anywhere, it's going to show up more out here than it will any place else, which is what I was trying to show in the previous slide, talking about the kink. You can work with it. I did, and basically I got it down to a much smoother curve. Perfect, no, but a lot of that right there is because I'm also up against the rail joiner. The rail joiner is straight. The rail joiner is going to try to make this straight. So those pliers help you give that rail joiner just a little bit of a curve. Just an FYI. Obviously, tools that I use for a lot of those kinds of things that you see all the time. One of the tools that I will tell you that you want to keep a good eye on and not overuse is this tool. I use it for a lot of things. It has a cutting blade on it, but I don't cut my tracks after it's installed. Put caps in it because you will be cutting at an angle. I don't care how you grab that tool, you're going to be cutting at an angle when you slice the rail. And besides that, this particular tool I will tell you not to use because it's too thick. This kerf right here, you need to go in and figure out what you're going to do with the hole you just left in the track, because it's for HO, it's really too big. It'll cause you, in some cases, there are thinner abrasive cutting blades that you can use, but I will tell you to spend $10 or $12 and get the flex tool, because you can literally lay that thing in between the track and make a perpendicular cut. You can use the smaller ceramic or whatever type blade they have, and make a much smaller kerf when you cut the track if you're putting gaps in it. And like I said, I got that one off of I got that one at Walmart, and I think it cost me like $13, $13 or $14. But you can buy them off Amazon for, I've seen them as low as $8 and as high as $20. But yeah, it's a cheap tool for solving the problem. The cut that I'm talking about earlier off of the Dremel, yeah, this is the problem. Because now you got to go in and you got to straighten it up in order to do this. So you're going to end up doing either filling the track or even worse, and you're not paying attention to what you're doing. The blade gets away from you a little bit, and oops, you nick the track behind it, as you can see in the second photo right here. Yeah, you really didn't hurt anything. Will wheels run across that? Oh yeah. It's just, I'm also into aesthetics, and it's just ugly. So yeah, you're going to cut pieces, you're going to fill them. Did that. Styrene works great. I can either use CA or epoxy for the glue to put it in there. I put it back down. On the tool earlier, you saw that I had a brush on it. Inserting that in there and using this brush tool and a Dremel will make short work of getting it to shape, and works quite well. Now, I'm not anti-gap, as can be seen from this picture. This was a showing up for work on a friend's layout, and looking at it and saying, they didn't do as good a job as I thought they did on laying down some of the track. And then the reason is that every joint was soldered. Expansion and contraction, if with heat.
I'm sorry?
And expansion.
Yeah, it was a nice little sun bath.
Am I okay?
It was a nice little sun.
Anyway, the track, needless to say, bowed. It was an easy, it's an easy fix. It's no big deal. You need to put an expansion gap, and I will tell you, put an expansion gap every 10, 15 feet, whatever you want to do. It doesn't take a lot, and you don't have to have a big gap. If you use the ceramic cutter like I was showing earlier, every once in a while, it allows the track to expand and contract as needed, and it doesn't introduce any points by which you're looking for derailment. But as you can see, the lack of expansion joints cause all kinds of interesting problems. My favorite tool for determining gaps is a truck. I don't care whose truck you use. I just make sure that it works well. Whether this, I think this particular one is an O-gauge truck, an O-scale truck, and so what I do is I ride the finger, I put my finger on top, and then you can feel what's going on with the track. You can feel the lean. If it leans, you can feel the bumps if it bumps, and you can feel the dips as you go across them. It's one of those things that, hey, it's my favorite tool for checking out track. One of the other things that, one of the biggest problems I've seen that most people have are homemade track. I don't care if you use Fast Track's jigs or not. You need to put your skills to use, because the Fast Track jigs are usually on. But if you'll notice, somebody forgot to put the cutout for the seat of this rail on this side. You got one over here, but for whatever reason, it didn't make it there. I end up seeing little things like this where they bowed the track when they put it down, because if you look at the size of the ties, there's a difference between in the tie heights all the way across this particular switch, which caused the points to ride up, because the points are a little more free floated because of the way the track is designed. And so now all of a sudden you got a bump coming in. Now they did do a good job of rounding off the edge when going into the points, but it doesn't make any difference. This is still bad construction any way you want to look at it. And you can see in this photo how much of a rise coming along this way is, or how much of a drop off if you're coming from the other direction you've got. Not good. The troubles that my eyes have seen. And this is one of the charts I came across. This is on the NMR a website, and they came across and gave us characteristics on the curved rail radius. This is for the turnout. Obviously, the straight part goes straight through. So this is on a straight track with the the right hand or left hand, turnout, and that tells us what like a number 4 track or number 6 track, what the curve actually is if you were to extend that curve naturally. Because one of the problems we were talking about kinks earlier is mating up to that curve. Most people don't have a problem mating into the yard if they're going to follow the curve. But if you're going to go off right or left, it's amazing how quick this gets to be a problem. I found another table to go with this earlier, and this is the radius that seems to work for each of the various switches. And I like this because it gave me a measure. Now, I don't have I have a 15-inch gauge, obviously, because for my number 4. A lot of people can't use the number 4, but on my track, because I got it smooth enough where I do my track work, that it works quite well. But then like on a number 6, that's a 43-inch radius. Well, I can put a 36 or a 42-inch radius coming off of this pretty easily. And allows me to match up, helps me prevent kinks. Again, trucks. This is again another someone I do not know. I cannot tell you to this day why this track piece of turnout this was butchered, but you can see where I think they were trying to find one of the tie joints between the jumpers between the outside rails and the inside rails on the various places. I mean, they butchered this thing up so bad, I just tore it out and threw it away and started over. We do things to ourselves that I really do not always understand. Obviously, this is a track that's coming off of a out of a jig that has been built, because you should be able to recognize the ties and obviously the gapping that goes in with identifying like fast tracks, jig and jig work. And overall this is not too terribly bad, except for one problem. They screwed up the point. That is a flat point. If you've got a truck that's slightly out of gauge, and I mean slightly, it might even actually come close to putting it on the NMR age gauge, and then all of a sudden the wheel set for that truck catches it. It's a bit of a problem. This doesn't have to be a knife point, but at the same time, it can't be flat. That's just track work waiting. Oh, that's a disaster waiting to happen. Now, this one was even more interesting to me, because this particular point came down. Oops, sorry, accidentally clicked. Came down, and this is curved. It's not as easy to see here, but this is one curve, and depending upon the wheel set, again, depends upon where you pick up on this frog. And it was not derailing engines per se. It didn't seem to do that. It was usually one of the other freight cars that would catch on it. Because we don't always, monitor our equipment as well as we probably should. And so sometimes wheel sets, get out of standards, and it causes us some issues. But one of the biggest problems I find is the old infamous glue, either glue or in this case solder. Somebody was soldering that joint and forgot to clean it up. Yeah, I'm not much to be said there. I'll let it go for what it is. It's fairly obvious. Favorite tools. This file right here, this point shaping file, that's off of the Fast Tracks website. And that tool to me is the best file I've got in my toolbox when it comes to working with points. Flat out, your frogs and points. This tool is great. This is the PBL file that I like it because of its size and the fact that it had a handle on it, so it's easy to grab. But just an FYI, those are my favorite tools for working with some of the track work and so forth. And this is also the PBL nippers, because for whatever reason I can get them to cut a really nice piece of track, very flat. I don't have to do a whole lot of work to reshape it to make it match up well. So, from that standpoint, those were the things that I use. And then obviously the NMRA standard gauge, that's in my toolbox. I have many of them. The website I was talking about for the posting the clinic, for picking up all the other pieces.
Thank you, Jeff. And if you have any questions, please put them in the chat, and I'll go through them now with Jeff to make the process a little more efficient. But yeah, Jim Brown, my friend in Vancouver, says, for what it's worth, he used a slotted Homosote roadbed, then he coats it and fills in the gaps with pre-mixed drywall mix, and then sands it and seals it with a good latex paint, and that seems to protect everything from that excess moisture from maybe the dilute glue getting into it. So yeah, sealing it seems to be a good idea for that.
Well, sealing is one of the things that a lot of people didn't do, and I've gone through a number of people's tracks, and then they put the ballast down. And what are you putting down with ballast? The one thing that Homosote absolutely loves is water.
Water, yeah. You dilute white glue, right? 50-50 or whatever it might be, yeah. Mark Evans says he recently used Masonite spline with Homosote roadbed, and he said the Masonite was really easy to flex and bend, but a really bit of a pain to sand the top smooth and to get it and to get it smooth. Doing that was a nightmare.
That is true.
Yep. And then he says he then sand his Homosote before laying ties and rail. George Aaron says, and I agree with him. Your diagram of the different Walthers and Pico and Atlas and so on track was really interesting, like how different they were just for what is ostensibly code 83. But George says the web appears to be also very different between some of those. So the rail joiners are going to be really hard to work if you put the wrong ones. Right. Yep. Chuck Proudfoot says the East Bay model engineers in the 70s had all sorts of problems with expansion, 125 feet of track and a 50-degree temperature difference during shows. So yeah, that will do it.
Yeah, we'd run around with people cutting gaps bigger, and then the week after the show, we'd have to go fill in the joints because the wheels would fall off.
Yes. I don't understand. That's one of the things about using the Dremel that I have, because you're coming in at probably anywhere from a 30 to 45 degree angle to make that cut. And then all of a sudden you got to clean it up.
Yeah, Ron Gutman says that the best choice for plywood is Baltic birch. It's flat, stable, and has no voids. And yes, it is more expensive.
Yeah, and there's also cabinet grade plywood that you can also get that will also do a good job. Not as expensive as the other, but it's a better grade. There's what they call a decking grade, construction grade plywood that is absolutely horrible because it's designed to be put down as a sheet, and it's used like on roofs.
Yep.
And things of that nature. So it's going to be covered up. So they don't care what it looks like.
Yep. Yep. Gerald Harper says, I found styrofoam can work well with an aluminium frame on a portable layout, but keep the track back from the edge and will always lay a cork strip under the track itself. From Gerald.
Understand it. The only problem I have with that is that Homosote, the foam, I don't know what it is. Don't lean on it.
Yep.
I love foam. Don't get me wrong. I love it for all kinds of things, but if you lean on it, it distorts.
Yep. And Chuck Proudfoot says, I use 15-ply furniture grade plywood.
Okay.
Yeah, so that sounds expensive, but great. Okay. That's it for the questions. Thank you, guys. I'll hand it back to Jerry to move along.
Thank you.
Thanks so much, and thanks particularly to Jeff. It's been a really interesting exercise in all the things we've probably all done wrong at one point or another in the hobby, and the learning soldering skills seems to be one that's always a challenge for most people. But it's worth it once you get good at it.